Welcome! Today we are going to be getting Python to solve Sudoku. Now, Sudoku is a simple game. You have a 9 by 9 grid, and in each row, column, and square, you can only have one of the numbers from 1 to 9. So in this square, there's 3, 9, 5, and 4, so I couldn't put any of those numbers in. So I could put 1, for example, or a 7, but I couldn't put a 7 in here, because there's a 7 here as well, and there's a 7 here. So this is the web Sudoku I've chosen. It's just called web Sudoku, mainly because it's the simplest one, so I think it'll be easiest for Python to manage. So, how are we going to go about doing this? Well, step 1 is getting the program to see the board. So, we use Python to take a screenshot of this area, do some image processing to remove everything except for the numbers, then we split it up into 81 squares, get PyTesseract to recognize which number is in which square, and then, once we know which number is where, we can use a Python module that I found called PySudoku, a simple Python program that generates and solves Sudoku puzzles. So all we need to do is feed in the grid, it gives us the solution, and then we go back to web Sudoku and just get Python to enter all the numbers. Should be simple enough. I've already done something of the sort with the Python chimp test, and the issue it's having at the moment is for some reason the website keeps jumping across, which is a problem because Python is done based on pixel coordinates, so if the screen is not in exactly the right position, it's not going to work, but there are ways around this. So, step 1 is to find all the coordinates and the sizes of these boxes. Then, step 2 is to get some code up. Let's get right into the action. Well, action, it's coding. But you know, pretend it's action, pretend it's a Fast and Furious 26 movie that you're watching. Thanks, web Sudoku. Helpful as ever. Really helps me identify exactly where the mistake I made was. So, the code works. I have, of course, tested it beforehand, and I just thought I'd walk you through it to help you understand it. So, here at the top we have some imports. We've got Python to do the clicking and the movement, PyTesseract to do number recognition, time just for waiting, Pill is for your image manipulation, Sudoku does, well, the actual solving, and string is used for whitelisting later on. So first it waits 5 seconds and then presses right 10 times. I just did that because for some reason the web page automatically moves to the left, just so it's calibrated. Then it takes a screenshot of the Sudoku grid, makes it grayscale, and basically anything that's black it keeps black, and anything that's not, so like the grey bits, that's mostly the actual grid, that it just deletes, turns into white. Helps a lot with the number recognition. This is the actual grid construction. So, of course, there's 9 columns and 9 rows, so that's why those are done 9 times. And then each iteration, PyTesseract is given one of the squares, and it recognizes the number. Of course, if it's a number, it adds it. If it doesn't see anything there, it just adds a 0. And then this little print just lets me know how far through PyTesseract is in the process. Then we get on to using the actual Sudoku function. Make a new puzzle, and then solve it. Really, this library is great. You just do puzzle.solve and it's sorted, you know? And then, because it actually outputs in a weird format, not in the grid, I turn it into a string, and here I just whitelist it. So I extract only the numbers from it, and this bit just gets rid of some of the unwanted numbers at the start. Then it calibrates it again by pressing to the right, clicks on the first square, and this bit is just entering all the numbers. So, as I'm sure you will definitely want to see, let's take a look at it in action. So here we are at Web Sudoku, and now we just wait for the program to start. There we go. So when it moves the mouse, that's just letting me know that it's taken the image, and I can tab out. So this is the shell. Here you can see what it's actually seeing. So now it's on the 4th row because computers count from 0, 5, 0. Oh, where are we? And I think something's gone wrong because it's seeing an awful lot of zeros. Damn it! I hate when it works when I'm not. As you might expect, it didn't recognise half the numbers, so Sudoku has a hard time solving that. That's really disappointing. Let's try that again. Hopefully it recognises the numbers better this time. It's the issue with PyTestRact, it's a bit temperamental sometimes. And no, now it's just not working. As soon as I start recording, it just stops working. Damn it, PyTestRact! And as usual, most problems have the most stupid solutions. Turns out the reason it wasn't working was because I didn't have this web page scroll down all the way to the bottom. Yeah. But now it is working. So, there's the 600083002, and so on and so on. I won't bore you with all of this, I'll just cut it to the end. Now that we are approaching 88, which is the last one, I'll tab back into here. Now we watch as it just fills in the rest of the grid. Beautiful. Watch it not be right. Yeah, it's not right. That's really annoying. Back to the drawing board. And after fixing a really simple number error, where I'd accidentally wrote a 3 instead of a 4, now it should work. It's looking better already, I can't see any mistakes off the bat. Fantastic. Congratulations, you solved this Sudoku. So there you have it. But that was an easy puzzle. As you can see, these have all been easy puzzles. And the thing is, because the Python solver, it will solve any Sudoku puzzle. So there's no real point in me showing you an evil puzzle. It's just with less numbers. In fact, this might be easier actually because there's less room for PyTestRact to make mistakes. But nevertheless, let's have a crack at this evil puzzle as well while we're at it. So the board is being recognised fine. As you can see, there's much more zeros because there's much fewer numbers. And then for some reason the website's done that thing again, where it goes all the way over to the left. But yeah. It's probably some kind of Sudoku speedrun. Oh, see, it did it again there. But Python already started typing, so it's fine. And then the moment of truth. How am I doing? I showed 2 minutes 5 seconds. That's fantastic. I assume. Actually, do you think humans can... Right. Here we are. The fastest time to complete a very easy Sudoku puzzle was 1 minute 24 seconds. So my program was 2 minutes and 5 seconds. It'll be the same for an easy puzzle as well, because it doesn't make a difference. It's not exactly a record, but still pretty fast. Look, here we have some 2 minutes 53 seconds. 2 minutes 16 seconds, rookie numbers. But yeah, the Sudoku is solved. If you enjoyed this episode, please like, comment and subscribe. It really does help this channel out a lot, and it would mean the world to me, as a small YouTuber, and that. Hopefully you learned something from this episode. If you have any questions, please don't hesitate to contact me either in the description below, in the description below, in the comments below, or on my Discord server, which is in the description below. And if you enjoyed this episode, stick around on my channel, and I'll be seeing you for more like this in another episode.